how the flood and drought, the climate affects our life and economy of the country, and how this background of the CRIP project, and give us a very detailed and comprehensive outline of the Kalani Valley flood mitigation project. Thank you very much for your valuable presentation, Engineer Alakanda. And our next presentation, according to our schedule, is by Dr. P.B. Dharmasena. And we have shared his profile. His presentation is Ancient Water Management in Sri Lanka. As you know, we have a good history of irrigation in Sri Lanka. And he's presently the team leader for the project improving system efficiency and water productivity for Ministry of Irrigation. And I cordially invite Dr. Dharmasena to give his presentation. Thank you.
Okay, thank you very much. Good evening to all. This is another presentation today. Thank you very much for giving me the space for talking about this ancient water management in Sri Lanka. Now, yes, when you say water management, we believe that always it's meant for irrigation. But in Sri Lanka, this ancient system, there are a lot of things, not only for food production and irrigation. They use this water for human needs. Then there's another kind of historical evidence to say that they have done very old system, rainwater harvesting. And also they love environment and they wanted to protect environment, flora, fauna, and other part. Then they use water for city planning, especially Anuradhapura and Sigiriya. Then they made these efforts to make the parks, landscaping, and so many things. Water springs you can see from Sigiriya fountains. Administrative boundaries also they decided based on the water. Then natural disaster mitigation, flood, drought, cyclone, epidemics. So there are a lot of things. Now, I just want to tell you that they have a very good master plan in ancient Sri Lanka. They have put it at country level, then from river basin to river basin, then even from reservoir to reservoir, there are a lot of giant canals. Even at sub-watershed level, sometimes we call cascades. Then village level and field level. So they have a good master plan. Unfortunately, it has been collapsed after some time due to war and some epidemics, but still there are remnants. Now, for example, here you can see a lot of giant canals. We know that one is from Kalavawa to Tisavawa, Basavakulam, and there are diversion from this main canal to Nachadu, Nuvarava. So many giant canals they have constructed. And also, we can see that there's a very beautiful and specific characteristics that is brought by Yodalo Giant Canal running from Kalavawa to Tisavawa. You can see that it's a single bank canal. It runs around contour, almost contour. Water is collected from upstream while it is running through this landscape, then water is released to both sides. Generally, irrigation canal is constructed to uh, distribute water to downstream, but here you can see that there are places where you get water from upstream and again direct to upstream. Then canal moves along tank upstreams because they didn't want to disturb these small tanks. It goes around the tank. And now what we did that we have done some modifications to these giant canals. So it really shortened in 1970s with the accelerated Mahavali program. Now you can see when you go along these canals, all these tanks are sedimented, and those are not productive now at the moment. And also from reservoir to reservoir they have done, especially if you take ancient Anuradhapura system, Anuradhapura city, city gets water from another river basin, Kala Oya, and it feeds Nachadu, Noravava, Tisavava, Basavakulama, and Bulankulama. So that the city is replenished with groundwater. That is one of the important things that we have to look into. When you visit Ranmasuyan, just below Tisavava, you will find a good figure there. I just realized that, and I am going to see here. It's a stargate. They say stargate. So it's the gate to move to other planets. But when you go through and see, study this and see, it could be the city plan of ancient Anuradhapura kingdom. Now you will find that water cordon around this plan, and there are a lot of other features there. When you compare this one in our old city plan, you will see that there are a lot of similarities. There are entrance gates. Here also there are entrance gates into the inner city. And also water cordon is represented by different reservoirs. So what I wanted to tell you that this inner city is protected with lot of things, and you know that there are water culture evolved in this Anuradhapura kingdom. Water cordon around the kingdom, Tisava, Nuravava, Vasavakulam, and Bulankulam, focused to enrich groundwater in the kingdom. I am going to suggest you to see that why they wanted to replenish this city with groundwater. Now, when you construct a reservoir, generally we wanted to feed the command areas, but here paddy lands and these tanks are relatively low, and catchments are not adequate, so that they have done their best to feed these tanks from other river basin. Alluvial soil, just around this city, there are two rivers moving there. One is Malatuay, the other one is Helpanway. So you can expect some alluvial soils there. And how these gigantic structures could be sustained, like Ruvanelsai, Jetwanarami, Abbegiri, and so on these alluvial soils? That is the question that we have. When you take bedrock, you can find two types of rocks like Charnockite genus and granitic gneiss. What we can expect that those groundwater coming from these tanks, which will really pressurize something in the layer, sand layer, and it can sustain these huge structures. Now, these are the rocks that we find there underneath. And there's another evidence that you can see a lot of ponds, wells and some cordons to protect these palaces. All these are given some kind of features to monitor the water level. Monitor the water level. You can see that the steps, not only to get down into this one, but there are layers like. So one can monitor the water level. If there's a drop of this water level, they will have to be replenished. Otherwise, groundwater will deplete, and that can be a big hazard. So what I want to tell you that there are cities being sunk due to depletion of groundwater table. For examples, one is Beijing in China by 11 centimeter per year. Then Mexico by 28 centimeter per year. Jakarta in Indonesia by 28 centimeter per year. Bangkok in Thailand by 12 centimeter per year. So those are due to, they found that it's due to groundwater depletion. Now, when you take this world map, you can see a lot of cities now at the moment sinking. So we have to be very careful about this. There are signs. Some vertical cracks now we can observe in Ruanilse. 4 cracks in Jetavanarame. Most probably due to groundwater depletion because of the other examples that we can get from other countries. Then there's another map you can see when you put all these big reservoirs, old reservoirs, those are just below this 150 meter MASL. So how they put this, how they plan this, we can't see any kind of instruments or satellite or whatever it is. No technology could be really traced. Then at small scale, there are a lot of clusters of tanks which are feeding water to big reservoirs. So that is why we say that they are so much worried about these floods and drought, so that they had come up with networks of reservoirs to absorb water during rainy season and keep this water for dry seasons. So one of the things that we found that those tanks are organized in clusters. We call tank cascade systems later. And what we have observed recently that it's not only water movement, but also there are a lot of other features organized in these systems. So we had to change our definition from water-based to ecology-based definitions. Now, this is one of the things that we studied at the village level. When we say tank, hamlet, and paddy field, and there are some other Chena lands in the upstream, but we found that that is organized in a very, very scientific manner to keep this water more clean by having sediment trap here, we call Godavala. Then there are 2 soil ridges either side of this upstream, we call IESL, to divert this sediment polluted water, and we get a very clean water. And here we get Perahana, that is filter in a meadow. Then there are some trees, tree belts here, Gascommana, and during flood time, the water can be spilled, and here there is a seepage from these tanks which will be polluted with a lot of salts, and it can be trapped in this reservation we call Katakadu. There are a lot of things can be explained in this system, but that will ensure the sustainability of this. Even here, the paddy field is, you can see that Godavala, Perahana, Gascommana, and IESL here, that will make a good kind of controlling devices to make the water unpolluted. Then the other way, that downstream, Katakadu, Gangoda, Isbambe, Huel and Land, they will contribute to feed this vela or paddy lands. with lot of fertility enhancement. And here, when we go back to our ancient kingdoms, one is Sigiriya. A lot of people believe that it's a creation of King Khasya, but it's not true. About 3,000 years ago, before the Prince Kashyap came into that, this has been constructed. So you can see that there are canals to convey water from top to bottom, like this in Sigiriya. And also there are places like this to create water springs with some kind of nozzles. When it rains, you can see even now today, there are some kind of springs coming up. This emerges due to water coming from somewhere else, but not under that much pressure. But you know that we can imagine that the kind of water springs would have come up about 15 to 20 feet. How they could be able to get the pressure for this sun? That is our question. Now, when you see that the landscape of this, you will find another rock with special features, like not the natural, but there can be some kind of intervention from the community. That is Pidurangala. From Pidurangal to Sigiriya, the direct distance is about 1 kilometer. And we will find the special features of this top of this rock, Pidurangala. You will find convex and concave top plains. So we suspect that these Sigiriya kings must have been in need of clean drinking water. They must have tried something, rainwater harvesting systems in this Pidurangala. Why we want to tell you that there are some remnants of this clay pipes which can be sealed. And when we trace this one, you can see that the pathway can be like this. So it can be a difference of elevations about more than 100. Yes, more than 100. And you can see the edges are generally inwardly shaped, not the outside, so that the water can be collected here. And also there are a lot of large rocks at the bottom of this this mountain, Pidurangala rock. And you can see that the cracks are just perpendicular to the natural decay lines. So that it's not natural, it can be sometime man-made, I should say. And when you take this one, you will see that the whole flow pitch is about 5 acres. And finally, water will be collected here and it will go out. So there are some convex portion of this rock and the concave. We have visited very recently. I can remember that we had a team with Dr. Kamal Laksari, and we found that it's a real innovative work they must have done. They are during the old historical era. And you can see some lines that they have constructed to divert water from the ridge to the bottom. Then there are some other canals we could see on the top of this rock. Those are man-made because otherwise the shape must have been something like this. But here you can see that the edges are sharp. And that can be utilized to divert all this water with some kind of filtering process. And finally, it can come here to concentrate into one point through a water filter in ponds. So finally, it will come here and disappear somewhere here. And there's another balancing stone you can find on the top of this rock. This balancing stone, you can have a small feature here with like a mirror image of this whole Pidurangala rock top. Like this, you can see the same shape, like this. So generally our ancestors must have had some kind of mold, stone mold, to prepare the rainwater harvesting model. It is the mirror image of the flow pitch. Why we want to study this and come up with some kind of concepts? Because when you calculate using present rainfall pattern, somebody could have had about 10,000 cubic meters per year fresh water without any pollution. If you take this 10,000 meter water, volume of water, what does it mean? Okay, forget about all these as a myth, but when you get 10,000 cubic meters to the people who are living around, sometime you know that at present they are threatened with chronic renal disease, kidney disease. Now what I say that even during rainy period, now you can see this water is flowing, concentrated into this area and flowing like this. So what I suggest that why we are curious about this history, if the daily drinking water requirement is 3 liters per head, that kingdom, the people must have had the opportunity to use this around 9,000 people population. And that is what we need. But there are some other things that I have to tell about ancient water management system. One is that this Maduruvaya, old sluice. When you see that, you will see some unshaped big stone boards, and those will be fitted into, and there are some air cavities. So why they wanted to have it? The same era, 6th century BC, we find everywhere these prehistoric burial sites. Ibbankatu, Andarawava, Bellankadavala, Yangway, like that. So same kind of shapes we could find. They are in these burial sites and these sluices. So we can consider this as a initial part of in the evolutionary process of this ancient sluice. You can find in 3rd century BC here and 5th century AD. This is Urisitavava and coming to Kalavava. So that there's a evolutionary process must have taken place to get this Bisokotua principle later as a invention of these Sri Lankans. Why we want to study this one? Because there's a big pressure because of the head of this water height, and it has to be dissipated. So they have constructed here pressure releasing chamber. That is the principle of old Bisokotua. Then there are some other small things that to release water from small tanks at the sluice, they must have had some kind of devices. So this is one of these we call Katahorova. Katahorova means piece of these pipes put together like this, organized in a way that one can remove part of that, and this part will cover a water mass here, which will really move through this one, and it will feed paddy area. So they must have had some kind of mathematical methods to see that how much the water volume this one pipe piece can release to feed the paddy field. So they have that done and they have measured this one. You must have heard of this Diakatapahana. That's a natural rock, man-made rock, which could be, they are labeled at different levels. And when you release this water from Katahora, so part of the volume will go into that 10 feet. So how we can say that the paddy field is fed enough? For that really they have used one wooden one called Karahan Kote. They put this on log with some cuts like this. So they have different portion of lands to feed in different sizes. For example, here you have 3 different sizes of lands, A1, A2, A3. Then they have to pass this flow in different discharges like Q1, Q2, and Q3. How they could be able to do this? They have changed the depth and the width here and here. So, for example, if you take these 3 outlets from one sluice, when they open the sluice, the water will flow from these 3 in 3 different discharges. So once they close the sluice at a time, all these paddy fields are fed, but those are different areas. They have not used any kind of mathematical formula, but they have some kind of scientific way of doing it. So this Karahan Kote is another example to see the wisdom of our water management system. So what I suggest you to investigate all these, and we'll have to sit together, engineers, water scientists, agriculturists, archaeologists, all together, and see how we can use this cognizance from the past to improve our knowledge, saying that sometime you will find miracles. So those miracles can be explained by using modern science, but see the wisdom that we had in the past, invented our ancestors. Those are few things that I wanted to make during a very short period. So thank you very much. And if there is any kind of clarification I make, I am waiting for that. Thank you very much for all. Thanks.
Yeah, thank you very much, Dr. Dharmasena, for this very valuable presentation. I think he has shared a lot of valuable information on how the ancient irrigation management is used to use for human needs, preserving the environment, and mitigating the natural disasters. I think it's very valuable for our younger engineers to get this information which you can't find in textbooks or any other sources. Further this, I think especially the tank cascade systems, river basin canals, cooling reservoirs, and the rainwater housing systems such as Pidurangal, I think those are the very valuable information he has shared with us with a lot of research done to enlighten our engineers on this ancient water management practice by in Sri Lanka. Thank you very much, Dr. Dharmasen, again on this valuable lecture. Now, I think we have about another, according to our schedule, we have about another 25 minutes for any questions to be shared with us. So I kindly request the audience to raise any questions you have on this Dr. Dharmasena's lecture or previous two lectures done by Professor Ratnayaka and Engineer Alakanda, so that they will provide answers for your queries.
Yeah, yes, thank you, Gihan. And thank you all three resource persons today, Professor Mrs. Niranjini Ratnayake. Madam, thank you very much. She's here with us actually in the at the IESL headquarters. Then Engineer DCS Alakanda and Dr. Dharmasena. So thank you very much for all of you for sharing your valuable knowledge. And I think today our members could gather lots of new information. So it was a very good mix, I think. In the first lecture from Madam Mrs. Niranjani Ratnayake, we could hear about the current topic, that is the climate impacts on the water sector. So there we could hear lots of new ideas, and especially for all the practitioners in the water sector. And then we discussed about one of the important projects, the Kalani floods. We always hear every year during monsoons, and then we just forget it. I think this time we will see something practically happening. There's a major project going on, as she explained. And in fact, Water Forum is planning to conduct a detailed discussion or a kind of a panel discussion on this project in the coming days. We were planning it earlier, but we could not get the resource persons as they were very busy with the project work. So the earlier engineer Alakhan, the project director, agreed to come with us, and I think in the future we'll be able to conduct a detailed event on this project itself, and so that our members will get they get the opportunity to learn more about the project. And today we got an introduction to the project. And then we had a very interesting lecture from Dr. Dharmasena, I think, how our ancient used water management techniques. I think I actually met Dr. Dharmasena accidentally, and so I decided to get him in our program. So he has wealth of information on this ancient water management. Very interesting. I think it's very useful, and also I think you all will agree with me when we look at the way they have developed in the past. I think with all this new technology, I think we are still halfway. I think still we are to learn a lot more from our ancient practices. So in this topic also, we are planning to do more. I also happened to go with him to Bidurangal, and there we found lots of interesting information, and we are planning to go further on this in the future as the Water Forum. And now actually we can give time, we have enough time to discuss interesting questions from all of you. And Madam, I think you have one question to the Engineer Alakand about the Kalin project. Yeah, Kaushalya, can we, yeah. Engineer Alakand, I think you are there still with us. Yeah.
Dr. Naksiri, now I got one question. Wonder if principles of IWRM were used in identifying solutions. I think,
Yeah, that's right.
yeah.
Yes.
So I think the short answer is yes. Normally IWRM, we are, that concept we are, are very heavily using in the Mahaveli irrigation and mainly the system. Because now earlier, as Dr. Dharmasena mentioned, people think that water is only for irrigation, or water is, agencies are thinking water is irrigation, agencies think that water is mainly for irrigation, and the water board and other agencies think that is only for drinking. I think now the thinking and understanding of most of the engineers are different. Now people are thinking how can we handle this water sector in the integrated manner. So I think if you take this Kalani flood protection program, I have seen some people are just thinking we are spending a lot of money. I think yesterday also I have noted some statement. this is very capital intensive project, and just to use this investment to send flood water just to see, so which is not true. Because now if you take this system, like, that embankment is one part, but upstream reservoirs and the power production, at the same time, the water board is very much keen on drinking water requirement for beyond 2025. They have prepared a long-term plan, but no sources for that. So therefore, VOA is their main requirement. So what we did, they have started feasibility study using VOA location. They need some 25 MCM for their beyond 2025 requirements. Because just imagine, can Ambatale intake or Vaливita intake can provide water for these high-rise buildings and port city and Colombo development? So it's not possible. So what we did, we talked to the World Bank Water Board, and so their requirement is 25 MCM requirement for a certain capacity reservoir. What we have discussed with them, give us that reservoir, we will do the feasibility, we will do the construction for some 50 MCM or some around almost double their requirement. But we have given some guarantee for them. We will not touch that their requirement, 25 MCM, and the remaining space we will use for flood water retention. So in that way, we have worked together and try to then take that Ambatale salinity barrier. Now, if something happen, even that saline water is now reaching to the Ambatale. Now, Kalutara city is very badly affected because of this salinity issue. And now here, what we are going to do, we are going to construct permanent structure. Then during the flood time, we can open all the gates. Those are flap gates. And we are trying to, prevent that salinity will go up to even Kaduela, Vaливita and all in future. So what we are going to do, we are going to prevent some very huge threat that can happen to Colombo drinking water system. So all these things are working together. At the same time, if there are any, the potential places, we are doing the transbasin. But if there are any big, level difference, now some are telling us, why can't we transfer that Kalani water to the Mahaveli River at Ginikattena? So we have tested almost all the places. Because now in Ginikattena, Kalani River is nearly about, say, 150 meters below the Mahaveli level. So how can we do it? So all these things. At the same time, so we have, I think the answer to this question is yes, and we have considered whatever the possible, the work in the integrated manner. Thank you.
Yeah, thank you, Engineer Alakanda, for the elaborated answer. And there's, I think you can continue. There's one more question to you. Kaushalya, can we post it to Engineer Alakanda? Yeah.
Yes, sir. There is a question. Do you think pumping for flood mitigation is sustainable?
So, can you repeat it again?
Yes, sir. Do you think pumping for flood mitigation is sustainable? The question is from Jude. Do you think pumping for flood mitigation is sustainable?
I can't say yes or no immediately. But the thing is, now when we are talking about this, all the possible technologies that we can use, in some places we have to, now if you take some, I am not saying the flood water, now actually if we have not done this damage to the river bank and the floodplain, we don't want this much of investments. But what we have done, we have damaged up to the river bank and now try to reverse it, which is not acceptable. So therefore, now take that the Megapolis Ministry is doing number of pump stations at Kitampaua, not Kitampaua, St. Sebastian, Ambatale, and Kitampaua and Oliamol, then Petiagoda and all. Why they are doing it? Because now if you take the Madhivala area, then Parliament area water, now that water has to be pumped back to the river. Otherwise, they can't, that doesn't mean we can't take every drop of water coming from rain back to the river. But this is a minimization. So this is not very effective because, the huge maintenance cost, and this will be used, say once a year maybe, or more than that. So all these things has to be, therefore, very huge pump station will not be very sustainable. But some the medium size, small size pumps will have to be introduced depending on the location. So, but other thing is, if there are any possibility to the divert water to some other basins or upstream reservoirs, that will be the best solution. But this is what I can say about these pump stations.
Yeah, Engineer Lakanda, yes, so the same about the same issue. There's a suggestion from, I think, this Dr. Mantri Tilaka. Why not charge groundwater? Gampa district is suffering without water. I think this is a good idea. Maybe your consultants looking into this aspects also. It's clear, I think, to
What
you.
is that the question? Gampaha?
Why not we recharge ground pumping up, sending it to recharge the groundwater? I think in other countries they do this. He says Gampaha is suffering without. There are new methods for rapid recharge.
No, we can think about all these things, and at the same time, for Gampa suffering some drinking water, and now Gampa is having a huge flood issue because of this Attanagalu and all these things. So I think we can consider the Dr. Mantri Tilaka's suggestion, and I am willing to listen to most of the suggestions, because there is no only one person or one solution for that. It should be a combination of most of the things. So I am willing to welcome all the suggestions. That is what even we had with meetings with the treasury and all, come up with some solution which can be implementable. So it is, we can discuss further, and we can try to, that we can use our investments for any kind of investigations or research. Thank you.
Yeah, I think we can discuss further in the event that we are planning to conduct in the future about the detailed program on this project. So all these options can be discussed. And there's a question to Dr. Dharmasena. I think Kaushalya, can you forward it? Yeah.
The question is for Dr. Dharmasena as well as Engineer Alakanda. It is from Engineer Uday Kumar. Can we use ancient technology to mitigate climate change? Can we use ancient technology to mitigate climate change?
That has to be investigated. That is the short answer that I can give. Now, for example, if you take the tank village system, they have designed that to address the problem of flood and drought, so that even during this present scenario, we have due to climate change, and we can improve that based on the technology that they had, but not exactly as it is, but we can learn from ancient technology and improve it according to the present situation. That is what I think about this.
Thank you very much, sir. For Dharmasena, sir, there is another question from Dr. Banduni. It's about, would you please let us know a little about Agueva concept?
I couldn't follow that one. Yes.
Would you please let us know a little bit about Agueva concept?
In that model, again, there was a concept called Agueva. In that sketch with village tank model, I remember
I didn't come across that. I didn't come across that.
Was it there? Or if Dr. Banduni is there, you can. Are you there, Dr. Banduni?
Yeah, it's a kind of, can you hear me?
Yes, yeah, please.
Yeah, the aguava is something that what I learned, what I have learned, it's kind of a thing before water coming into the main reservoir, that there are some small tanks, we call it aguava. So it's kind of actually an engineering concept. It works as a sedimentation tanks. Sometimes aguava, there are before the reservoir or sometimes in the side of the reservoir. Like that, we can make a concept like several type of sedimentation tanks. So that's what I researched, and so I thought that you may have some better wording or better explanation of aguava than what we have find out.
The word, I think, in different way that we heard. Now, we have these clusters of tanks. One is Kulueva, that's in the wild, and it can be used for drinking purposes of wildlife. And there are some other, like Kayam in dry zone. This Kayam is the sediment trap. That is not meant for any irrigation, but to trap the sediment or debris coming from chain lands. Then there are some other different types of tanks, Agueva or Kalingueva. I don't know the word that came from which source. I am not sure.
It's kind of a, agu pillar. So like that, the agu is something like that. The wording is agu.
Okay, that is something like pond tank, not immediate upstream. Maybe which is somewhat similar to Kayam Weber. That is to take all these debris and sediments and release clean water. There's another small one, water holes. That is Godavala. That is upstream sediment trap. Maybe words may be different, but there are things like that, depressions and man-made water holes and tanks to make the system sustainable to prevent the sedimentation of the main tanks. There can be different structures in different words.
Thank you. So Mineri River, it had aguava, so that's what we studied. Or I researched. I did some research on it. So anyway, so I think in future I can contact you to get more explanation in this regard. Thank you, sir.
Thank you very much, madam. We have 2 more questions for Engineer Alakanda. Sir, first question is, can you elaborate more on the flood bunds along the river, especially before Hangmella?
What is that? Can you elaborate?
Elaborate more on the flood bunds along the river, especially before Hangmella. The question is from Varanasi, Engineer Varanasi. Below Hangmella.
Yeah, now from Hangmella to Colombo, that river mouth, we have identified some, specific with the chainage, what kind of bunds could be constructed depending on the land availability and the acquisition and considering the very valuable buildings available in that stretch. But above Hangmella for some nearly about 8 to 10 kilometer distance, we are not going to construct embankments very close to the river bank. So we are trying to link some, there are a lot of plantation area and a lot of lands available, and the affected number of families or people are not much. So we are identified some, linking various, the highlands by earth embankments or whatever the type, and try to protect the people by providing some separate, protection covering that, like ring bunds or something for the people who are living in those areas. Because now this flood management, you can't expect some 100%, you can't you can't avoid that impact. So impact will be there, but we are trying to minimize the things. But there is no any continuous two flood bands both sides of the river above Hangwell, but it will be a link in connecting some highlands and try to protect the villages or families available that area. So I think we have had lot of discussions with the people living there and their livelihood, and try to adapt this concept. And at the same time, there will be some suggestion. Now, if you take some 100-year protection, now sometimes if you ensure that say 50%, 50-year protection, or the even little less than that one, so we will be able to minimize the height of this bank. For example, I can tell you now, this is not above Hangwell situation. If you take the Kalupalam and up to the river mouth, the bank, the bunt height will be 1 meter, 1.5 meter. So it's not a very big height. So I think now we have discussed with the Colombo Metra Colombo upgrading project team. So they need some small or some sort of bunt both sides of the river. Otherwise, their pump stations will not be fully utilized, because now they can't pump that water